A positive surge is an unsteady open channel flow resulting from a sudden increase in water depth. For a positive surge, the application of the momentum principle to the unsteady flow is relatively simple. The unsteady flow conditions are solved as a quasi-steady flow, using the momentum equation developed for the hydraulic jump. A positive surge is also called a hydraulic jump in translation, a compression wave, a bore. It may be observed during inland propagation of tsunami on storm surge bore, in estuaries affected by large tidal range when there are tidal bores, in man-made waterways during gate operation, and at the leading edge of an extreme flash flood including downbreak wave. The following movie shows the tidal bore of the Qiantang River in the city of Hangzhou, China, in 2014. The camera was facing downstream and the bore propagated upstream. A positive surge may be analyzed as a quasi-steady flow, considering a positive surge propagating upstream against an initially steady flow, for example following downstream gate closure. The surge is an unsteady flow for an observer standing on the bank, on the left, but it is seen as someone traveling with the surge at the celerity u, as a steady flow, a quasi-steady hydraulic jump. The quasi-steady flow analogy is illustrated in the following short movie in a laboratory. In this laboratory experiment, the last frame of the movie shows a side view of the positive surge, which is nearly identical to a side view of a hydraulic jump. For a rectangular horizontal channel, considering the control volume across the front of the surge traveling at a celerity u, the continuity and momentum principle can be developed. They give a series of two relationships between the flow property upstream and downstream of the positive surge, that is the flow property before and after the bore. In this relationship, the Freud numbers are defined in terms of the surge propagation in using the relative surge celerity. A related situation is the positive surge traveling in the downstream direction. The solution of the continuity and momentum principle are identical, but the definition of the Freud number are corrected to be defined in the frame of reference in translation with the surge. The continuity and momentum equations give a system of two equations with three unknowns: the new flow condition, d2 and v2, and the surge celerity, u. A further equation is required, that is a boundary condition, for example, the new discharge after gate closure. A positive surge is a large disturbance that can travel upstream against a supercritical flow. A key feature is that the bore absorbs random disturbances on both sides of the surge, and this makes the positive surge stable and self-perpetuating. Tidal bores and tsunami news bore can travel far inland. For example, the first movie of the Qiantang River bore was recorded nearly 120 km inland. The above development assumed an idealistic positive surge generation. In practice, the generation of the positive surge traveling upstream is a very turbulent transient. It is associated with a rapid acceleration of the surge leading edge immediately after gate operation, followed by some deceleration before the bore celerity becomes nearly constant. Such a transient turbulent process cannot be modeled with simple one-dimensional flow theory.